I'm gonna break down the equation that literally powers the stars, and also bombs, and also, yeah, E equals mc². You've probably heard of it. E equals mc² is energy equals mass times the speed of light squared. What the hell does that mean? What is that? In order to figure out what it means, we have to back up. Okay, so we're gonna take it all the way back to particles. What is a particle? A particle is an excitation in a quantum field. So if you imagine like a grid, and you imagine little like blips, quantum field is anything that has a discrete property. So it either is or is not. That brings us to energy. What is energy? Energy is the intensity of that excitation. That will bring us to the next question, which is what is mass? This is a question that I had a really hard time wrapping my mind around because it's really confusing, but I'm going to try to explain it in the way that I understood it. Mass is energy confined to an arbitrary system. Okay, so what does that mean though? An arbitrary system. Okay, so let's imagine that we have a proton. That's the proton. Inside the proton, we have 3 quarks. Those are the 3 quarks. Let's imagine that we take the 3 quarks out of the proton. Okay? Now it looks like that. Let's say you put them on a scale. You put these 3 quarks on one side of the scale, and then you put a proton, just a regular proton, on the other side, and you weigh them. Guess what? Guess what happens? Bet you never guessed. The proton weighs like 10 times as much as the 3 quarks. What? I thought the quarks were the thing that made up the proton. This is where it gets super duper interesting. Most of the energy that's inside of a proton isn't actually stored in the quarks themselves, but it's actually stored in the bonds that connect them. So what proton really means is it's kind of the imaginary boundary for quarks. So imagine the quarks are attached by a spring, and they're kind of bouncing around. The volume is the boundaries of the spring, how far they can go from each other before they have to eventually come back. So imagine this is the proton, but actually everything is being held together. What's holding the quarks together is actually something called the gluon field, which is the energy that holds everything together. If you remove the proton, the boundaries, you lose a ton of energy because a lot of the energy is stored in the bonds that hold things together. Back to the original statement that mass is energy confined to an arbitrary system. The arbitrary system would be volume. Let's talk about mass and energy and the relationship, because in E equals mc², it essentially states that energy equals mass, just in a different form. First, I kind of want to clarify the difference between mass and weight. So weight is the effect that gravity has on something. When gravity is pushing towards the center of something, its force will be strongest towards the center. When you hear people say, oh, I want to lose weight, they're not actually saying they want to lose weight. You can't really lose weight. Weight is the effect of gravity. You can't really lose that unless you go to the top of Mount Everest or go to the moon. But you can lose mass. Mass is the stuff. If you took somebody and put them on the moon, they would weigh less, but they would have the exact same mass. What's the deal with photons then? Why the heck don't photons have mass but they have energy? That doesn't make any sense. That brings me to the Higgs field. The Higgs field is another crucial component in understanding the idea of E equals mc². The Higgs field is basically a frame of reference for particles. Anything that interacts with it has mass. Poor photons don't interact with the Higgs field, and therefore they are doomed to a life without a frame of reference. When particles are in a moving state, they actually have more energy than something that's not moving. And you might be like, well, obviously. But the real question is, why does that happen? And it's because you have kinetic energy on top of whatever energy that they have. I think that a good way to visualize it is, imagine if you had a tennis ball and you filled it with a bunch of springs and beads and all sorts of little tiny little things in there. If you held it and you weighed it, it would give you a number, and that would be the mass. If you took the tennis ball and you threw it and you were somehow able to measure it while it's in motion, it would technically have a higher mass and higher energy because all the stuff inside of it is also moving, which is really cool. All the stuff inside of it is bouncing around, which is energy. You measure the amount of energy inside of the arbitrary system, you get mass. Okay, now this is where it gets even more interesting and even more cool. Imagine if you have an atom. You take that atom and you split it into 2. Say that you took the 2 that you split and you put them back together. They wouldn't equal the same as the original atom that you broke them apart from. What the heck? What the heck? Where the heck is all that extra energy going? Well, Einstein decided to try and figure it out. That's E equals mc². E equals mc² is a way to figure out where all the missing energy goes during the conversion between energy and mass. And since the energy is stored in a bond, when you break something apart, the energy that was in that bond shoots. It goes crazy. Now, the different bonds between particles can be much stronger than other bonds. Imagine a spring. if you compress that spring, it's got tons of potential energy. That's like an atomic bomb. So those bonds are containing so much energy that when they break, they're catastrophic. However, you also have other different types of bonds, like chemical bonds. Chemical bonds, that's like a stick of dynamite. It's like if you pushed a spring a little tiny bit, and then you broke it, and then it has a reaction. It's still massive. But an atomic bond is like, it's impossible to even comprehend the amount of energy that's contained in such a tiny bond. So the process is called fission. Now, the way that the sun works is the complete opposite. It's called fusion, and it's because there's so much mass and so much gravity and so much force being pushed down that basically everything is being pushed together instead of pulled apart. Which, since E equals mc², it means that it goes both ways. You can have two opposite parts of that equation. You can have fission, you can have fusion. That is so freaking cool. Einstein was totally onto something, and he definitely had to get out of Germany after coming up with that and realizing what that meant, because it would not be good if Hitler got his hands on that. Thank God Einstein got out of Germany. Why the heck does an electron have mass, but a photon doesn't have mass? It doesn't make any sense. What the heck? A photon is like the Wi-Fi of the universe. It connects everything, and there's no mass, so nothing stops it. It just keeps on going, which is super cool. When I put my hand out, and my window's open right now, so it's sunlight coming into my room, and everything touching my hand has been traveling through the universe for like freaking ever. That's like awesome. You remember when I mentioned the Higgs field earlier? Photons don't interact with the Higgs field. There's no proper way to measure a photon because it never stops moving. I learned that the speed of light is just a constant. It doesn't really mean anything other than a little less than infinity. Or I guess a lot less than infinity. Basically, it's just a super duper 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 super fast thing. And there's no real reason why it is that way. It just is. It's like Planck's constant. Planck's constant, I believe, is to describe something so tiny that's not infinitely small, but probably just below that. E equals mc² is like the most important equation ever, and it's what makes everything kind of work. It's what makes the stars shine, and it's what made nuclear weapons. It's the same thing that powers nuclear reactors. It's the missing energy from the breaking of bonds. It's literally so cool, and it's actually incredible. I can't even imagine how somebody would just come up with that and figure that out. Oh my god, it's so cool. I wish I could figure something like that out. It's just so cool. It's literally the way that the universe works, and you can trace it back to like every single thing ever. Because you have to break it down to particles, you have to figure out what energies, you have to figure out what masses, you have to figure out what it means to square the speed of light. What?